These are some examples of the relationship between frequency, velocity, and wavelength. So for question 1, a wave hits the shore 3 times every 2 seconds. Calculate the frequency of the wave. So what we have to do is we need to find frequency of the wave. And we know that it hits the shore 3 times every 2 seconds. So the number of cycles is 3, and the time it takes to do that is 2 seconds. So we have our unknown and we have our knowns. So the equation for this to find frequency is cycles divided by time. And so when we plug our numbers in there, frequency is 3 cycles, and there's no units for that, divided by 2 seconds. And when we go to solve this equation, we just divide the numbers and we get 1.5 per second. It turns out is the unit, and per second is hertz. So that's how you do that. To calculate the period of the wave, it's very similar. So if we scroll back up a little bit, we know that we need to find our period, and that's a capital T. It's a very specific time, the period. We still know that the cycles is 3, and the time is still 2 seconds. So the formula for period is this capital T is time divided by cycles. So it's the inverse. In other words, all you have to do is take the inverse of the frequency and you will get the period. But to finish our setup here, we'll take the time, which is 2 seconds, divided by the 3 cycles, and so our period is 0.66666 repeating, so we round that to the 100th place seconds, and we will put a box around our final answer. And let's do the same for the one above so that we know that is our final answer. For this one, the frequency of the A note is 440 hertz. If the speed of sound in air is 340 meters per second, calculate the wavelength of the sound wave. So we start off just like we usually do with our 4 steps. We identify our givens and our unknown. In this case, the frequency of the A note is 440 hertz. The velocity of sound in air is 340 meters per second. And we want to know our wavelength, and that is the lambda symbol for wavelength. It's a Greek letter. The equation for this is that velocity of a wave is equal to the frequency times the wavelength. Just that simple. So when we have our givens and our unknown, we plug in our numbers and we find that 340 meters per second is equal to, and I like to use parentheses to keep everything organized, our 440 hertz, which as we remember is meaning per second, multiplied by our wavelength. And so we're going to solve this, but first let's simplify it just a little bit here. So we're going to take both sides. We need to get this lambda symbol by itself. So we're going to take both sides and divide it by the 440 hertz, just like that. That will of course cancel out here. This hertz, which is per second, will cancel out with the seconds there, the per seconds there. And when we finish this up, we find that our wavelength is 340 divided by 440, and that gives us a wavelength of 0.77 meters. And of course, we'll put our box around our final answer there. Slightly different setup, same basic principle, same equation, but this time we're going to have to find the frequency. It gives us a length of a wave is 5 meters from crest to crest, and it travels at 14 meters per second. What is the frequency? So this time we're given our wavelength from crest to crest is 5 meters. So we use the symbol for wavelength, which is our lambda, travels at 14 meters per second. That is our velocity. And we want to know the frequency, which is our script F, our fancy F for frequency. We use the same wave equation as before. Velocity is frequency times wavelength. And we plug in our numbers once again. So 14 meters per second is our velocity, equals, we don't know our frequency, and once again parentheses help, so that is frequency times the wavelength, which is 5 meters. Now we will solve this and put it on that side, but just to help simplify a little bit, let's do the work over here. So we will get that F frequency by itself by dividing both sides by 5 meters. That will, of course, cancel out the meters, the 5s, and the meters over here will cancel out with those meters. So when we do our calculations, our frequency is 14 per second divided by 5, which is going to give us 2.5 per second, which, of course, is hertz. Put a box around our final answer, and we are done.